So we studied about magnetic field, and now we are going to learn about magnetic field lines. So now we will learn about magnetic field lines. Okay, and we learned about magnetic field. So let's study about magnetic lines. So these are some features of magnetic field lines, and the first feature is that magnetic field lines is directed from north pole to south pole outside the magnet. So what we studied in first point, we studied that this is magnetic field lines, and how magnetic field lines, there are so many magnetic field lines. We can take a small circle, or we can take a large circle by changing the points of compass, and here we can see this is also field line. Okay, so magnetic field lines, you can uh, see the direction that outside from the magnet, the direction of magnetic field lines is like here. Okay, okay, if we complete this, so what it said, the direction of magnetic field lines from north pole to south pole outside. Okay, north pole, this is north pole, we know this is north pole, and this is our south pole. So the direction of magnetic field lines is from north pole to south pole outside, outside this. Okay, outside, this is outer side, so outer side. So at outside, the direction of magnetic field lines is from north to south. Okay, and inside, if I complete this, if I want to complete this, okay, if I want to complete this like this, okay, this is my magnet, and I'm drawing this. This is south pole and this is north pole. Okay, and we see the direction like this. Okay, so outside it is from north to south, and if I want to complete this, I can complete this like in this manner, and we can say the direction is south to north inside. Okay, so outside, the direction of magnetic field lines is north to south. You can also draw by using this compass, and we studied this. So the direction from outside is north to south, but inside the direction is south to north. Okay, again, if I want to complete this, I will do this. So inside it is south to north. The next point is magnetic field lines is a closed and continue curve. We know that magnetic field lines are closed curve. Closed curve means they are closed, they are not open. They can be completed by like this, or if I want to draw this, if I draw this is south pole and this is north pole. So it is the direction. Okay, so if I want to complete this, the direction, you can see how they are going in this direction. They are completing the path. Okay, they are completing the path. They are completing a path. So it is a closed path. Okay, and it is not an open path, so it is a closed path and continue curve. Continue means it is a continuous curve, not something which is discontinuous. You can see how this is a continue curve. This is a continue and continuous curve. This is how. So it is closed and continuous curve. Okay, the third point is The magnetic field lines are crowded near the pole where the magnetic field is strong, and are far apart near the middle of the magnet, are far from magnet where magnetic field is weak. So what does it mean? It means that these magnetic field lines we studied, that it is much crowded, and we can say it is much number, or they are in much density near poles, and as they go far they get far from apart. So if we want to check the intensity of magnetic field or power of magnetic field, or you can say power of magnetic field, okay, so the highest power, or we can say the highest intensity or the highest number of magnetic field lines which is present near pole, so much power, increased power is near poles, because we studied this on yesterday that they have to accumulate there, and they have to continue here, and they start from here. So anything which will come in contact with this portion will feel much amount of intensity, or okay, so anything will come near poles, okay, it will feel, either it will feel attraction or it will feel repulsion, but it will be very much more, okay. But the intensity of magnetic field lines here is comparatively very less, and intensity near this is much high, okay, and here the intensity is very less, because you can see that here the density, and there are so many magnetic field lines are present in this much area, and this much area we can see they are get separated, so they are less powerful, or they are less intense when they are in curvy form, or we can say they are apart from pole, okay. Now the next point, the magnetic field lines never intersect each other, because if they do so, there will be two direction of magnetic field at a point, which is not possible. This is very important point, that this is two magnets, these are two magnets, and it is corresponding poles, okay. So direction of magnetic field lines we know, okay. So these magnetic field lines, okay, so the two magnetic field lines cannot intersect each other. Cannot intersect each other means, if I place these magnetic magnets too close, if I place them close enough, okay, so it is its magnetic field, and it is its magnetic field, okay. So the magnetic field lines never intersect each other, never intersect each other. It means never cut each other, they have to be separate, okay. Magnetic field lines have a direction, and they have to be separate from another magnetic fields. That's why in this case it is having this direction, and it is having this direction, okay. So these magnetic field lines cannot cut each other, or cannot intersect each other, or cannot bypass from each other. So magnetic field lines have a particular direction, and they have particular area, so two magnetic field lines never intersect each other, they cannot intersect each other. Two magnetic field lines cannot intersect each other, okay. This is how you can see, this is how you can see. So definitely they cannot intersect each other, so you can see both of them having a different path and different lines. So it is the meaning that magnetic field lines cannot intersect each other. This is not possible anyhow. Field lines are parallel to each other, okay. Definitely we know that magnetic field lines are parallel to each other. This is a pole, this is north pole, sorry, this is south pole, and this is north pole, And Kisan beta, why are you late today? Kisan beta, why are you late today? If you have any problem, then tell me. I can start class a bit later, because if you will late, definitely you are attending a class and you are not getting so much things. So tell me if any reason, if you are why you are getting late. Okay, your sister was using device. So I will inform I will inform sir, so that we can shift our class a bit. Okay, we can change the time of our class. That's why, because no, I want to change 10 minutes, because I told whole thing about magnetic field lines. I told, and now right now I'm just explaining the last point. Before this, I have told 4 points related to magnetic field lines. So if I will revise this, definitely it will time consuming. And if I will not revise this, definitely you will not you will not get benefited from this. So what can I do? What should I do? Just tell me. Should I revise this or should I continue? So these are two magnets, okay? And what we studied, that in these two magnets, we studied that two magnets are having their separate magnetic fields. Okay, two magnets are having their separate magnetic fields. These are separate magnetic fields. These are separate magnetic fields. We studied this, that these two magnets, each magnet is having its separate magnetic field, and these separate magnetic field. So one thing I just told okay. So I'm just using I'm revising this just for you, that we can see that at this side the intensity of, or the number of, or the density, number or power or anything of magnetic field lines is more. So we can say the intensity, okay, or the power of magnetic field lines is very high at poles, very high at poles. Okay, because you can see that they are, all the magnetic field lines are originating from only this area. Even there are 1,000 magnetic field lines, even we draw 1,000 magnetic field lines, you can draw 1,000 magnetic field lines, they have very restricted originating area, that is this area. So that's why the poles have very much high magnetic field. Anything which will come in contact this from this area, either it will repulse this that thing, or I will either it will get attract something if I'm using another magnet, and if it will come in contact with this particular area. So for, either it is attracting or either it is repulsing, it will, this magnet will feel a huge and great and much amount of force. Why so? Because it will feel huge amount of force, because this is having much amount of magnetic field lines. If you originate 1,000 field lines, if you originate 10,000 field lines, definitely they will originate only from this zone. We know that all of the magnetic field lines are originating from these poles. So at poles, the intensity or the power of magnetic field lines is, or magnetic field is much high. Magnetic field, okay, magnetic field is much high, and number of magnetic field lines is much higher at poles. But as they go apart, as they move on, they will go apart. You can see now they are much aparted from each other. So at this side, the power of magnetic field is less. At boundaries, the power of magnetic field lines or magnetic field is very less. Okay, this is one thing I told you. Second thing I'm going to tell you, that two magnetic field lines never intersect each other. What does it mean? That these are two magnets, south north, and they are having their separating magnetic fields. Okay, they are separate, but if I make them close enough, okay, if I make them close enough, this is south, this is north, this is south, this is north, and if I make them close enough, okay, so here it's field line, okay, and here it's field line, okay, and if I grow more field line, like will be like this, okay, so the direction will like it is going here and it is going here, okay, so you can see this thing, you can see this thing, in this thing or particular in this thing or particularly in this thing, two magnetic field lines are crossing each other. You can see they are crossing each other, they are crossing each other, okay, so this is not possible. Two magnetic field lines cannot cross each other, two magnetic field line cannot cut each other, or appropriate meaning is intersect. That means they cannot go like this, they should be parallel, okay. One thing is that first thing, the first thing is that they originate from here, and this region is much more powerful. Second thing is here that magnetic field lines should not intersect each other. It means that should not cut each other, they should be in parallel. If you draw 100 magnetic field lines, if you draw 1000 magnetic field lines, it's very okay if you draw like this, because they are parallel. In each and every case we have seen that these magnetic field lines are parallel. You can see that all of them are parallel, all of them are parallel. But if I put another magnet here, if I put another magnet here and it is going like this, okay, if it is going like this, so you can see something, you can see this thing, you can see this thing, it is like this, okay, it is something like this. So this point is known as the point of intersect. It means that they should not intersect or should not cut each other in any case. So this is the another process, another quality of magnetic field lines, that they should be parallel, but they cannot intersect each other, okay. So this is another property of magnetic field lines. So we studied five properties of magnetic field lines. I'm just revising you just for you, just Fazan, I'm revising this only for you, okay, that these are magnetic field lines and how it works. This is south pole, this is north pole. We studied the direction, okay, very well. We studied the direction. You can draw thousands of magnetic field lines, there is no problem. So as they will go apart from original magnet, if you draw 1000 magnetic field line by using compass, it's okay, it will form. As they go apart, their intensity will comparatively decreasing. It means that these magnetic field lines is more powerful, but these magnetic field lines is comparatively less powerful. And if you want to draw more magnetic field lines, if you want to draw more, you can draw so many till the magnetic field exists, okay, and the level will come, or the position will come when there will be no magnetic field and no compass needle deflection. Suppose you have drawn 100 magnetic field lines, and time will come when this magnet will not show a magnetic field. And okay, I'm using this magnet in my laboratory, and suppose this is a big magnet and it will work only for laboratory, but I cannot draw magnetic field line for this magnet from my home or outside from school, because each and everything has a limit. So you can draw magnetic field lines, but after some time or after drawing some magnetic field lines, there will be no deflection of compass, because it will lost its field or it will lost its power. Because you know, a single magnet, how much a single magnet can acquire area to show its magnetic field. Everything has a limited power, okay. So this is final magnetic field line, okay, suppose this is final, it is final, but this is much lesser powerful comparative to this, okay. And this area is always an evergreen area, and it shows much this pole region will show much amount of magnetic effect, okay, because you know, this is each and every magnetic field line is originating from these two poles, and they are having much intensity. So our question is that this is magnetic field line, so it goes north to south from outside. You can see we have drawn this magnetic field line by using this compass, how the needle will diffract and how the needle will show us show us the direction. So this magnetic field line show north to south outside. Okay, but if I want to complete the circle, okay, this is a complete circle, you can see this is a complete circle, this is a complete circle, and the direction I can say it will be like this. So from outside they are showing path from north to south, but inside they are showing path from south to north. Okay, so these things you have to be clear, that outside they are showing path which is north to south. We know the direction, we have drawn that, how the compass needle will show us path, how we draw this. Okay, we did this yesterday. And if I want to complete this, it will be like this. And there is a complete circle, you can see there is a complete circle, there is a complete circle, there is a complete circle. Okay, like this. So this is our magnet, and this is a complete circle. And the direction, don't forget, everything is about direction. Okay, if you forgot this, then you cannot do anything with this chapter. So just remember about direction. So north to south outside, north to south, and inside the magnet. Okay, inside the magnet it is south to north. So these are some properties of magnetic field line. They cannot intersect each other. They are very intense at poles, and they should have to be in parallel manner. Okay, they cannot intersect each other. They have much intensity at poles, and it is a complete circle. You can see it is a complete circle. We can see it is a complete circle, north to south outside and south to north inside. So these are some properties of magnetic field line. Now we are going to understand, we are going to learn about another process, another question, which is known as magnetic field due to a current straight conductor. What is a straight conductor? A straight conductor is something that if I draw a circuit, this is my key. Okay, I can use a resistance or a rheostat. I will tell you what is rheostat. This is rheostat. Okay, and it does not need to blow a bulb, so it will be positive and it will be negative. So if I am using a copper wire here, this is a copper wire. Okay, so this copper wire is in straight position. It is in straight position. Okay, neither it is in circular form, neither it is in another form. It is just a straight wire. That's why it is known as straight conductor. Anything you can use another type of metal, but if it is if it is present in straight line, okay, like this straight line, so this is known as the straight conductor. So how the electricity will move? Electricity will move like this. Electricity will move like this. Okay, so we are going to complete this. Now assume and suppose, okay, assume and suppose that these are two conductors. We studied this. We studied this. We studied this. Just give me 2 minutes. Yeah, this one. Okay, do you remember this one? Do you remember this one? In this case, we saw that how the electricity will conduct, it is showing this direction. Okay, So definitely it is positive pole and this is negative pole. And the compass, the needle of the compass is deflected to here. And in this case, the direction is here. In this case, the direction is here and the deflection is here. Okay. And in this case, the direction is here and deflection is here. This is the deflection. Okay. This is the deflection. Okay. Here, this is the deflection. So in this case, the direction is here and deflection is of needle is here. And in second case, the direction of electricity or current is here and the deflection of needle is here. Okay, so why these things come or why these things appear, this is our question. Okay, why the deflection takes place in different direction each and every time there is a deflection. Each and every time there is a deflection. So here I'm telling you that this is my conductor. Okay, and it is attached with a battery. Okay, so this is positive terminal and this is negative terminal. Okay, I'm not using anything else right now, I'm just using this. Okay, so how electricity will pass like this. Okay, I'm using a second case. Okay, and here I have changed the battery. Now this is my negative side and this is my positive side, and the direction of current is like here. Okay, so here the direction of is current like this and here the direction of current like here. Okay, so how the needle will get deflect? Okay, if I put compass, there will be two directions definitely. In one direction, the compass, needle of the compass will move in this direction, and another case it will move in this direction. Okay, so each and every time we have to find it, and there will be thousand questions in your paper that how the needle of the compass will get deflect. So this is a simple rule. Okay, this is a simple rule. Okay, like this. Okay, and I'm going to show you a trick. If the direction of current, okay, if the direction of the current, if the direction of current is like this, so there are two directions of current. Okay, so this is the direction of current, this is the direction of current, this is the direction of current. Okay, and this is the direction of magnetic field line, or we can say if something is passing from this. Okay, if some current is passing in this, it will form a magnetic field line. Okay, and if current is passing like this, it will form a magnetic field line. Okay, so this is the direction of magnetic field line. What is magnetic field line? As we are going to as we are, this is our circuit. Okay, and if this is my copper wire. Okay, so this is positive terminal and this is negative terminal, so current will flow like this, so current will flow in this direction. Okay, so if this copper wire is connected with electricity, it will work as electromagnet. We studied this. Electromagnet means when any metal conduct electricity, it will convert to magnet. Any metal plus electricity, any metal plus electricity is equals to electromagnet. Electromagnet. Okay, so it will electromagnet. Okay, so definitely there will be south pole and there will be north pole. We studied this. So now it is working like a magnet. And if it is working like a magnet, so as the magnets have magnetic field around this magnet is having magnetic field around this magnet is having magnetic field and magnetic lines. Okay, we know each and every magnet has two poles, south and north pole. So just consider that this is south pole and this is north pole, and definitely they are having magnetic field lines, because now this copper wire is now not more a metal, it is a electromagnet because it is present with electricity. Okay, so there will be magnetic field lines and there is particular direction of magnetic field lines, so it should be either or it should be either. So it is very great confusion, though our book provide us this idea that if the direction is here, you have to consider your thumb as you know, you have to consider your thumb as current, and the direction of finger should be as magnetic field line. So I'm going to show you a very simple thing. Okay, I'm going to show you a very simple thing. Okay, this is something. Okay, this is my finger. Okay, this is my finger, and these are my, sorry, this is my thumb. I'm just getting confused. This is my thumb and these are my fingers. Okay, so if this is my thumb, so if it is direction of current, then my fingers will show the direction of magnetic field. Okay, so here I am using right hand thumb rule. You should use right hand thumb rule. Okay, so this is my right hand, and in this right hand, each and every time you have to use your right hand to prove this rule. Okay, so if this is the direction of current, so these fingers will show the direction of magnetic field lines. So each and every time it is very difficult us to you know, explain this, so I'm just giving you a very simple idea. Don't forget this. Okay, now I'm provided with this question. Okay, I'm provided with this question. So here, okay, can you see me easily? Can you see me easily? I am drawing two lines. Okay, I'm drawing two lines. I'm drawing two lines. This is one line. Can you see this line? Can you see this line? Okay, so this is my line. Okay, this is my line. This is my line. I don't know how can I, you know, enlarge this video. I don't have any idea to enlarge this video, so that I will enlarge this video to how to do this. I'm not. Okay, pin my video. Yeah, this is how. Thanks for this help. And here, this is my page. Okay, this is my page, and this is my line. Okay, these two lines are showing us two different field lines. Sorry, electric current is the electric current direction of this is upward and direction of this is downwards. Okay, so you don't need to worry about this. Just I'm showing you a trick. Okay, take the pen which is of this type. Okay, this is a pen, and put this pen, the nib of this pen, in the direction of current. You will be provided with this type of question, that if the direction of this current like this, or the direction of current like this, or the direction of current is like this, or the direction of current like this. Okay, it can be in so many type of questions. So don't use this and this, it will make you confused. Don't look like this, I'm using this, I'm using this. Okay, I'm using this, I'm using this will definitely going to make you confused. It is very good for writing but not for practical use. So I'm just showing you a trick. Okay, take your pen. Okay, and it pen, this pen is like, it is opening and it is closing. Okay, so put this pen in the into the direction of electric current. Okay, so here the direction is upwards, here the direction is upwards, and I use this pen here. So the nib should be in the direction. Okay, here the nib is in this direction. Okay, here the nib is in this direction, and here the nib is in this direction. Okay, just open this. Okay, okay, open this and again close this. Okay, so when you close this, just imagine or concentrate the closing side for the, you know, this part, the lower part, which is white part. So I put this in direction. Okay, I put this in direction, in this direction I put this, and opening this, but I'm trying to close this from this lower part. I will close this from this lower part. Okay, so this lower part is, I'm closing this from lower part. Okay, so the direction of closing from the lower part is here. Here it is, here it is, here. Okay, and if I will use this, I'm using this. Okay, I'm using like this here. Okay, here. Okay, so again I'm going to open this. I'm opening this. Okay, I'm just opening this, I'm opening this, and I'm closing this. Okay, just consider the lower part. Lower part means this big part. Okay, all of us are having this type of pen. So I'm using this nib. I'm using this nib for downwards part, because this arrow indicates me that this is the direction of electricity. This is the direction of electric current. So I am placing my nib towards the direction of electric current. I'm opening this. Okay, and I'm closing this. This is the my direction of closing. Okay, so my direction of closing is here. It is here. Okay, so you can see in this side, this I put my pen. Just you need to do one thing, that if it will be like this direction, or if it will be like this direction. In this direction, I'm again opening this. I'm just opening this, and I closed this. Okay, just remember about this downwards part or lower part. While closing, I'm closing this. Okay, so it is closing in this direction. It is closing in this direction. Okay, and if I will use to for this, I'm just opening this, open this, and close this. Okay, so in closing, here I get this direction of closing, and here I'm getting this direction of closing. Okay, so this is how you can get two electric field directions while using this thumb rule. Never get. Okay, something you, how to manage this? I can't manage this. I don't know. I get confused in my exams. Okay, which is it is sure that this is the direction of electric current. Okay, but what about field lines? I have to put like this, or I have to put like this, or I have to put like this, and sometimes we do this, sometimes we do this. This rule is just good for writing, but for practical application, use this pen rule. Okay, I just did this much thing, this much stuff only to make you understand that how this pen rule works. Just to put this nib in the direction of magnetic direction of electricity. Just put in the direction of electricity. Okay, just put this pen in the direction of electric current, which will be provided you, or which will be from positive to negative. Just open this pen, open this pen. Okay, and close this pen. Okay, so direction of closing, you will be getting this. You can do it by yourself. So as I close this pen, I open this and I'm closing this pen. Okay, the nib should be towards the direction of electric current. So I open this and I close this. Okay, so close will like this. It is giving me the direction of this. Okay, you can do it by yourself. Okay, so this is how I get two directions. This is how I get two directions. Okay, and this is how I get two directions. Okay, now tell me if is it okay to you, or do you want more explanation? Is it okay to you? To understand what I'm really wanted to tell you? Okay, so this was all about my efforts. Okay, so don't get confused while doing this. So in this case, definitely if I put my pen, Okay, I'm putting my nib. This is my pen, this is nib of my pen, this is outer portion, and this is upper portion, and this is lower portion. So I will open my pen, and as I close my pen, the direction of closing will be here. Okay, so this rule is just good for writing, but it is not for practical application. If you are provided with this thing, and if you will use your thumb rule, okay, if you will use your thumb, right thumb, okay, this is known as right hand thumb rule. So definitely you will get confused about finding the direction of magnetic field line. But here I can easily find direction of my magnetic field line. So you can do it by yourself. Okay, I will give you question and you can do by yourself. If I'm using this, just put pen, needle, midpoint of pen, and uh, full last part of pen, and just open it and just close it. So direction of the closing will tell you that either direction will be here of closing or direction will be here of closing. Okay, don't remember opening direction, remember the closing direction. Okay, so you will get the magnetic field. So it is right hand rule. It is right hand rule, and this right hand rule is used to find the direction of this deflection. Okay, so this is okay. You will have next math class, so I am finishing my class right now and I will tell you this on tomorrow.